Okay, with 99, first problem here is rad negative 14 times rad negative 56. Now the first instinct that everyone's going to say is, oh, well, negative times negative is positive, so there's going to be, there's not going to be any imaginary numbers here. However, bear in mind, sometimes you have to think outside the textbook, all right, and understand that this is the section on imaginary numbers, which means there's got to be some kind of imaginary number part of it. So what we can do is we can see rad 14 as I rad 14, right? Because the negative is going to jump out and become an I, yes? Times I rad 56. All right? So now I'm going to do something, hopefully it doesn't confuse anybody. I'm going to go I rad, this is 7 times 2, yeah, 14. And then I'm going to do times I rad 7 times 8. Everyone okay with that so far? Okay, so now I'm going to rearrange some of this stuff. I'm going to say I squared, that's what these two have become, rad 7 times 7 is 49, times rad 2 times 8, which is 16. Well, the square root of 49 is 7. The square root of 16 is 4. What is I squared? Negative 1. So what is negative 1 times 7 times 4? Negative 28. Okay, a lot more complicated than what you guys might think it's going to be. Right? It's not just positive something and you find the root of it. You have to make sure that you guys are including those imaginary numbers. All right, that was number 99. Let's do number 101. 101 is 8 minus I squared minus 3 plus 2I squared. Who asked for this one? Who asked for 101? Nobody? All right, we'll skip it. 104. Who asked for 104? All right. 5 to the 3x over 5 to the 2x plus 1. Remember, when the bases are the same and they're being divided, who remembers what's happening to the exponents? Cameron. They are being subtracted. So that means I have a single base of 5, 3x. Now, here comes the real question. Is it 3x minus 2x plus 1, or is it 3x minus the whole thing? Minus the whole thing. So please keep that in mind. So this becomes 5 to the x minus 1, because we're going to distribute the whole thing. Okay? I'm sorry. Yeah, minus 1. Riley? Yes? Okay. 105. 2x to the negative 4y to the third over the big thing. Who asked for this one? Okay. All right. The whole thing is being raised to the negative 5 power, which means the whole thing is going to parachute to the top. So what I have is 2x to the negative 4, y to the third, times 2x to the fifth. Now, this y is going to stay to the negative 4. And the reason why is, what is the exponent that brought the whole thing up? What exponent brought the whole thing up? Trevor? The negative 5 at the time, right? And that's why the 5 turns positive. Nothing on the inside had any bearing on it moving. That's why this negative 4 is still negative. All right, let's do some algebraic manipulation here. 2 to the 5th power is 32. X to the 5th is x to the 25. Y to the negative 4 to the 5th is y to the negative 20. And that's all being multiplied by 2x to the negative 4, y to the third. 2 times 32 is 64. Those are gone. X to the negative 4 times x to the 25th. We add the exponent, so I get x to the 21st. And then y to the third minus y to the 20th is, or times y to the negative 20th, is y to the negative 17. However, what do I need to do with that negative exponent? Esther, push it down to the bottom. So I have 64x to the 21st over y to the 17. Okay. 109. Okay. Big thing. Negative 2x to the negative 4. Y to the third. Z squared. All over. 3x to the negative 2, z to the third, and all of that's being raised to the negative third power. Now, since the whole thing is being raised to the negative third power, the whole thing, Gregory, what's going to happen to everything on the inside? Everything is going to flip. Now, I'm going to get 3x and z. What type of exponent does x have? It's still got to be negative because this thing it flipped because of the negative 3, not because of itself. So z to the third over negative 2x to the negative fourth, y to the third, z squared. And now that's all being raised to the third power. I like to simplify things on the inside first. So let's see here. These two can switch sides, so I end up with, looks like 3x to the fourth. Let's see here. Z squared all over negative 2x squared, y to the third, z squared. I'm sorry. Yeah, z squared, sorry. Okay, so now I can go ahead and start reducing things. Daniel. Is it cubed? Oops, sorry. Thank you. Thank you, Daniel. Okay, so now I can start reducing things. And let's not forget, all this is being raised to the fifth power. Third. Sorry, I'm losing it here. Okay, so now let's handle the inside first. This is going to become 3 over 2, negative 2. X to the fourth over x squared is x squared. Those are gone. There's no y, so y to the third is going to stay on bottom. Z to the third over z squared is z to the first, and that's all being raised to the third power. Now we have to simplify everything on the inside with that exponent on the outside. 3 to the third is 27. X squared to the third is x to the sixth, z to the third, all over negative 8, y to the ninth. Okay, a little bit of a hard problem because there's a lot of inside and outside action happening. 118 is the last problem. Okay, x to the n over x to the 15. We already did this one? Alright, then I guess we won't do it. There should be 2 anyways. Alright, we'll pause. For these problems, you have to stay flexible. Sometimes it means you apply the exponent first. Sometimes it means you simplify the inside first. Maria, I'm going to simplify the inside first. It's just going to make it easier. Now, some people ended up with a problem with this on the quiz. Like, they started trying to get so many large numbers. Guys, smaller numbers are easier to work with, so simplify the inside. What's 2 over 4? 1/2. What is x to the sixth minus x to the negative fifth? What is 6 minus negative 5? Ayush. 11. And since it's positive, it's going to appear where? Up top. That's gone. Y to the negative 4, there's nothing to combine it with, and since it's negative, it's going to do what? Float to the bottom. Z over z. What's 1 minus negative 4? Positive 5. So therefore, it's going to appear up top. Now, Maria, remember the whole thing was being raised to the fourth power, right? So now, I just need to start applying this exponent in. 1 to the fourth power, that's easy. That's 1. X to the 11th to the 44th, we're going to multiply those exponents, so I get x to the 44. Z to the 5th to the 4th is going to be z to the 20th. 2 to the 4th is going to be 16. Y to the 4th is y to the 16. Okay, that one's a little odd because there's multiplication happening and there's exponentiation. So you got to make sure you don't get confused between what's being raised to an exponent and what's being multiplied. Daniel, what's up, buddy?